Hello everyone, welcome back to my YouTube channel. In this video, I'll start with a single phase transformer for introduction to electrical engineering as well as for elements of electrical engineering subjects for triple E students as well as for basics, and also it will help for transformers and generators, so-called electrical machines lab 1. So here a transformer, basically transforming. You should transform something from one place to other place. Means transferring an energy from one place to another place, or else transform a power from one place to other place by changing the voltage level or current level, but frequency should be fixed. So that a transformer is nothing but it's a static device. We are calling this as a AC device. It means of electrical power which is transferred from one part to other with desired change in voltage and current, but without change in frequency. So either you can step up the voltage or step down the voltage, step up the current or step down the current, but frequency should be fixed. So it's a static device which is used to transform power from one place to other place by changing voltage or current, but without changing frequency. In brief, it transfers electric power from one circuit to another circuit. It does so without change in frequency, and it accomplishes this with the help of electromagnetic induction. The reference is EMI. So that the transformer which works on the principle of mutual induction, which means that where the two electric circuits are in mutual inductive influence of each other. So that is called mutual inductance. The transformer which works on the principle of mutual inductance, before that you can see the symbolic representation of transformer. So here you can see two coils which are having, we are calling that as a windings. The one winding which is having a number of turns N1 and the other winding which is having the number of turns N2. The winding which is always connected across the source or supply is called as primary winding. So primary winding which is primary which is denoted by 1, so that N1 is nothing but number of turns in primary winding which is always connected across supply side. And another one, the winding which is always connected across load, we are calling that as a secondary winding. So whereas this secondary winding which is having number of turns N2, N1 is a number of turns in primary winding, N2 is a number of turns in secondary winding, and this primary winding which is always connected across supply, and the secondary winding which is always connected across load. You can see a parallel line, it is called core, and this is the symbolic representation of transformer. So it works on the principle of mutual inductance. That is nothing but mutual induction. Means we are giving supply to one coil, that coil produces the alternating flux, that flux links to the second coil. Due to that linkage of the flux, current induces as well as EMF induced in a secondary coil. So it is nothing but it produces two EMF. One is a self-induced EMF due to the supply side in a primary winding. Another one is mutually induced EMF, that is with the reference of, with the influence of primary winding flux. The EMF that will be produced in a secondary side, we are calling that as mutually induced EMF. So you can see the symbol, you can see the constructional diagram of transformer. The windings, you can see this rectangular shape, we are calling that as a core. And the vertical lines, you can see, observe this vertical line, we can call that as a limb. And this horizontal line, we are calling that as upside, and downside, we can call that as yoke. And on our limbs, we'll be wounding the primary winding and secondary winding. So the primary winding which is always connected across the supply, AC supply, and the secondary winding which is connected across the load. You can see the primary winding which is having the number of turns 1, 2, 3, 4, 5, 5 number of turns, and the secondary winding which is having 1, 2, 3, 4, 5, 6, 6 number of turns. It is nothing but the number of turns which are directly proportional to the EMF. If the number of turns increases, the voltage or EMF that will be increases. So that you can see in a primary side less number of turns, in a secondary side more number of turns. It is nothing but stepping up the voltage from lower to higher. So you can call this as a step up transformer. Based on the classification, which will be based on the number of turns, there are two types of transformers. One is a step up transformer, other one is a step down transformer. Step up transformer is which stepping up the voltage from lower to higher, and step down transformer is nothing but it is stepping down the voltage from higher to lower. So here you can see the working principle of transformer now. We are giving supply to the primary winding of single phase transformer. Current starts to flow in a primary winding. Due to the continuous flow of current in a primary winding, it produces the alternating flux. That flux started to flow in a core of transformer, and the produced flux is linking to the secondary winding. Due to this linkage of the flux in secondary winding, the secondary side it induces current as well as EMF. So that induced EMF we are calling that as a mutually induced EMF. At the same time, in primary winding across number of turns in one, it induces self-induced EMF. So this is how the transformer which works. This is called mutual induction. You are giving supply to the primary winding of the transformer, flux produced in a primary winding. That flux links to the secondary winding. Due to the linkage of the flux, alternating current that produced in a secondary side of the winding as well as EMF induced in a secondary side of the winding. Hence, it started to uh, giving supply to the load. So you can see here step up. The alternating supply input is having a less amplitude, output is having a more amplitude. So in detail, you can see when the current in a primary coil changes ping, as I explained, I already explained the same thing. You just see the textbook point of view. So when current in a primary coil changes being alternating in a nature, a changing a magnetic field is produced. That magnetic fields gets associated with the secondary through the soft iron core. Due to this magnetic flux linked, the secondary coil changes, which induces EMF in a secondary winding. So this is how the transformer which works. You are giving supply to the primary winding, produces a flux in a primary winding. That flux linking to the secondary winding due to the linkage of the flux, EMF induced in a secondary winding. That induced EMF we are calling that as a mutually induced EMF. So this transformer which consists of two elementary coils which are electrically separated. These two coils which are not connected electrically, but it is linked through common magnetic circuit. So you can call it as it is an electrically separated circuit, magnetically coupled circuit. So the coil in which electrical energy, you can see the coil in which the electrical energy is fed with the help of source, we're calling that as primary winding denoted by P. The winding which is always connected across the source, we are calling that as a primary winding. The winding which is always connected across the load, we are calling that as a secondary winding. That means the electrical energy is transformed to other winding which is connected to the load is called as a secondary winding is denoted by S. The two parallel lines in a symbol in a symbolic representation, you can see that two parallel line indicates a magnetic core. Thus, even though there is no electrical connection between these two windings, electrical energy is transferred from primary to secondary. So this is how the transformer which works. Okay. And the next is parts of transformer. It has a core. This core is made up of high grade silicon steel laminations, and its function is to carry the flux produced by the winding. And the next, which will be limb, the vertical portion of the core, we are calling that as a limb. So this limb will be used to carry the windings. And the yoke, the top and bottom horizontal portion of the yoke is of the core is called yoke. Windings, the coils which will be used are wound on the limbs and are insulated from each other, and its function is to carry the current and produce the flux. And conservator tank, so the function of this is to take up expansion and contraction of the oil without allowing it to come in contact with the air. And a breather, the device which extract the moisture from the air when the air is taken in and doesn't allow the oil to come in contact with the moisture. And the protection, the Buckles relay, it is a safety gas operated relay connected to the transformer. So the next is types of single phase transformer. I will explain in the next video. So I hope you are understanding this concept. If you are having any doubts regarding this, feel free to write in the comment box. The definition of transformer and symbolic representation, working principle, works on the principle of mutual induction, and the construction and working principle. In a working principle, you have to draw this diagram. They have to explain the working principle. The current which will be given to the primary winding from the source, it produces the flux linking to the secondary winding so that it induces EMF in a secondary. And you have to explain the primary winding, secondary winding, core, and the parts of transformer as well as core, limb, yoke, windings, conservator, breather, and buck relay. So thank you for watching this video. If you really like this video, do subscribe and share maximum. And if you're having any doubts, feel free to write in the comment box. Thank you. Have a nice day.